Hi, this is Miss Garcia. We will discuss the Theorem of Thales. The Theorem of Thales states that if points A, B, and C are on a circle, when line A and C is that diameter, then the angle ABC, so in this case ABC, that means this angle over here, it's a right angle. It doesn't matter if I move my circle or not. If I move my triangle, it doesn't matter. This one over here always has to be a right triangle. And I am going to explain how easily you can understand this concept of Thales. I'm going to use the angle sum theorem. The first thing that we need to know is that this semicircle has a diameter of AC. Now, my center of the circle is also the midpoint of this diameter. That is why I have these tick marks over here. So notice that if I change from A to O, the name for this segment, I can color R. And the reason is this is a radius. I can also say the same from O to C. I can say this is a radius. And this other segment over here, since it's coming from the center all the way to the edge of the circle, I can also say this is a radius. Now, I see that these triangles, I'm going to focus on the red one, is actually an isosceles triangle, because notice these two angles have the same measurement and these two sides have the same measurement. So I know isosceles, if the two sides are equal, the angle bases are equal. So notice over here in my angle sum theorem, I have two of those having 43 degrees. Now I have it also here when we have beta plus gamma. These are two of my angles. Now let's focus on the purple one. If you look at the purple triangle, I have the same game. I notice I have the radius, so these are the side of my isosceles triangle, and I also notice that the angles are equal. In this case, they are 47 degrees, and I have it noted here and also here. And with my variables, I know that is alpha and theta. And notice that all of them equal to 180 degrees. So now, if you notice at the second step, I can say that these two are equal, right? So instead of me writing gamma and delta, what I am going to say is, okay, I have another alpha and I have another beta. So in this case, I represent it here. Now that means that I have two of each. So I can factor out the 2, and I know that equals to 180. But then notice that when I divide by 2, the sum of alpha plus beta equals to 90 degrees. So this is how I can easily determine that, well, Thales is right. Anytime that I move, and I want you to focus on this side, on the right side, anytime that I move my point B, it doesn't matter which direction I'm putting it, I always get over here a right angle, which creates a right triangle inscribed in this circle. And that is what the Theorem of Thales is telling us.